Alrighty, so today we're going to have a quick chat about global and local minimums and maximums, and then we're going to have a look at using our calculator to actually find these things and to draw a few sketches. So let's just have a think about what is a global versus a local minimum or a maximum. A local maximum is a maximum at a point. It is not the highest point in the graph, it is just a point on the graph. So you can imagine here, this stationary point there is a local maximum. It is not a true maximum because on a cubic there is no upper bound. You could continue going up and you could get a larger point. Similarly, you could say the exact same thing about this point, except that it is a local minimum. It is not the smallest point on the entire function, however it is a point on that function. Having a look down here though, you can see once you add in domains, then you can see that you're going to get different versions of these local or global minimums and maximums. So a global maximum is the largest on the entire function. If we go back up and think for a second, we imagine a quadratic. What do we think about the turning point? Well, it's certainly a maximum, right? It certainly is a local maximum, but it is a global maximum. Well, the answer is, of course it is, because it is the highest point of that. So this would be a global maximum, this point right here. Alrighty, let's jump straight into a question. So for the cubic function, y is equal to 2x to the 3 minus 5x squared minus 2x plus 12, use technology to determine the maximum and minimum values for minus 1 less than or equal to x less than or equal to 3. Alrighty, so first of all, let's jump into the graph mode and let's sketch the picture. Alrighty, so let's delete all of this. Alrighty, so you can see I've already entered in the function into the y1, matches this one over here, and now I can just click draw and see what it looks like. Alrighty, so I've just set the view window to standard, but you could move up or right or left, or you could manually set your view window yourself. Now in this case I'm going to manually set it. Why? Because I've already been given a domain which is -1 to positive 3. Now for my own benefit, what I'm going to do is I'm just going to increase it by 1 on either side. So I'm going to go from -2 all the way up to positive 4 on the x-axis. And I'm just going to let the y-axis do whatever it's doing at the moment. And we should be able to get a pretty good picture of it. You're going to see at -1, we've got this point here. We've got some local maximum here, some local minimum here, and then what looks like potentially the global maximum over here at y is equal to x is equal to 3. Alright, so first of all, let's just find the values of the maximum and the minimum just using gsolve. So gsolve max is going to give us the local maximum right there. Let's write that down to 2 decimal places. Alrighty, now let's grab the minimum. So there's the local minimum. Let's write that down. Alrighty, and you might now wonder, okay, but how am I going to check the rest of the function, right? Because there could be local maximums, or sorry, global maximums or minimums anywhere on the function. Well, it turns out that the global maximums can only appear either at a local maximum or on the borderline. So now that I've worked out the 2 local points, we can see there's no other local minimums or maximums. All I need to do now is check the borders, which I can just do in standard run mode. So let's go through and do that. Alrighty, so for the for the lower bound, which is x equals -1, this is what we'll be evaluating. So after substituting in, you can see I've got 7 as the y coordinate. And as we can see, this can't be either a minimum or a maximum, for it is smaller than our local maximum and it is larger than our local minimum. So this point here is a nothing point. It is just the end point. Let's check the other end point, which is at x equals 3. And working that on the calculator, you can see we get it's equal to 15. So that means that this is in fact the global maximum, for it is larger than our other one. So that means that the global maximum is going to be, the local maximum is still going to be negative 0.18, 12.19. And for the local minimum, that means that since the borderlines, neither of the borderlines were smaller than the local minimum, that means that this local minimum is also a global minimum. Alrighty, so that is our function. And we can graphically prove this to ourselves by having a look at the function. You can see that the lower domain is neither the highest point nor the lowest point, but we can see that the upper domain is a little bit higher than our local maximum. So we've got a local maximum here, a local and global maximum here, and then a global maximum here at 3. Alrighty, thank you for watching. See you in the next one. Bye.